folks, here we are. We're into section 6.8. We're talking about graphing. Here we are. You know the normal pattern for each chapter. We develop some skills at the beginning, we solve some equations, and then we graph the related functions. Right? I have a young lady here, sitting here. Say hello.
Hi.
All right. First person who can identify that laughter and say hi will win a prize. How about that? There we go. Okay, ladies and gentlemen, today we're going to graph square root functions and cube root functions. Okay, a square root function's parent function is y equals the square root of x. All right, to graph any function, again, in the most basic ways, let's pick some numbers for x, plug them in for the equation, and figure out what y is. Now, what numbers am I allowed to plug in for x? Well, don't forget, when we want to get a real number for y, we're not allowed to plug negative numbers in. So what's the smallest number I'm allowed to square root? Oh, it's 0, right? We always want to start off by square rooting 0, all right? The next number that I like to square root is 1, okay? After that, the next number I like to square root is 2. No, not 2. How about 4? 4 is a good number to square root. When you graph square root functions, I expect to have 1, 2, 3 points. You only have to graph 3 points for me when you graph a square root function. Now let's actually do the math. What's the square root of 0? 0. What's the square root of 1? 1. So when x is 1, y is 1. And when x is 4, good save, y is 2. So I get these 3 points. 0, 0, 1, 1, and 4, 2. What you see is a graph that starts bending like this. Everybody see that? All right, and that's all it is to graph a square root function. Now, what's the domain of this function? Well, remember, domain says, look to your left. Where does this graph start on the left? Well, it starts at 0. Then look to your right. Where does it end on the right? Well, it doesn't end. It goes for infinity, doesn't it? Gosh, not going to lie, that's a good-looking infinity sign. Now, remember that infinity is always parentheses, all right? And since 0, I'm actually touching that point on the x, it's a bracket, right? All right, what about the range? Well, range says look down to up. What's the lowest that this graph goes down to? It goes down to there, so it goes down to 0. Okay, and what's the highest it goes up to? Well, again, it goes up to infinity, all right? So my domain and range are both 0 to infinity. Okay? All right, that's how you graph the parent function for the square root. All right? Now, let's take a look at how we graph the next parent function, cube root. These are the two main parent functions that we're going to graph when it comes to radicals. All right, now, what's the difference between square roots and cube roots, you ask yourself? Well, yeah, the main difference is the fact that square roots, you can't square root negatives, but cube roots, you are allowed to cube root a negative, right? Yeah. So what are the numbers I like to cube root? Well, there are 5 numbers I like to cube root. I like to cube root 0, I like to cube root -1, and I like to cube root -8. On the positive side, I like to cube root 1, and I like to cube root 8, right? Now, what is the cube root of -8? Well, the cube root of -8, isn't that -2? And the cube root of -1 is -1. And the cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2 again, right? So when I plug these values in for x, I get these values for y, and so this is what my function will look like. -8, 1, 2, 3, 4, 5, 6, 7, 8, -2 would be like right there. -1, -1 is right here. 0, 0, then 1, 1, and then 8, 2 will be like right here. What you're going to look at is a elongated looking S shape that looks like this and keeps on going up to the left, up to the right, and down to the left forever, right? So if you look at this graph, your domain for this guy is -infinity to +infinity. And your range for this guy is -infinity to +infinity. Because the graph goes forever to the left, agreed, and forever to the right. That's why the domain is that. And even though it's not growing fast, it is going down forever on the left and up forever on the right, okay? And that's your domain and the range. Now, what if I wanted to do some transformations or changes to that parent function? Well, we're going to use our old friend HAK, H-A and K, and these are our transformations. if I have y equals a times the nth root of x minus h plus k, again, won't h shift the graph to the right h units or to the left h units? Won't a stretch or compress it vertically? It might also reflect it over the x-axis. And lastly, won't k shift the graph up or down? Okay? Now, folks, I know that when you look at me, you know that as a teacher, you know, or as a person, when you look at me, you think of one word, and that word is lazy. Folks, we want to be lazy as we can when we graph, right? So when I have a graph like this, when I want to graph y equals 1/2 square root of x plus 2 minus 1, I don't want to do a lot of hard math. So does it make sense when I make my xy chart, and again for square root functions I only need 3 points, I want to pick numbers for x that are easy, that when I plug them into the radical, give me an easy number to square root, right? So here's what we do. What do we want to square root? Well, we want to square root of 0. We want to square root of 1, and we want to square root of 4, isn't it? All right. Well, what would you have to plug in for x if I wanted to get a 0 in here? Well, wouldn't I have to plug a -2 in for x? Because -2 plus 2 is 0. Well, would I have to plug in for x to get a 1? Wouldn't I have to plug a -1 in for x? All right? Because -1 plus 2 is 1. And lastly, if I wanted to get a 4, wouldn't I plug a 2 in for x? All right? Because 2 plus 2 is 4, right? Okay, now that I've figured out what I need to put in for x to get what I want, I'm actually going to plug those numbers in and evaluate for y, right? But you know what my old phrase is? What is this transformation on the x? What is my transformation on the x variable? Isn't it this plus 2, right? Which actually means subtract 2 from your numbers. Well, here's what I say. If you take what you want and you apply what you have, it'll tell you what you need, right? What you want, what you have, what you need. I want a 0. My transformation is left 2, so subtract 2. What's 0 minus 2? -2. I want a 1. I have a -2. I get a -1. I want a 4. I subtracted 2, so I need a 2, right? Now let's plug these numbers in and see what I get for y. So I'm going to do it right here. You're going to get y equals 1/2 square root of, the first one is -2 plus 2 minus 1. Y equals 1/2 of square root of, wasn't -2 plus 2 0? And then minus 1. Well, what's the square root of 0? Well, it's 0. And there's that beautiful easy math that I like because I'm lazy. All right, so I get y equals 1/2 times 0 minus 1. So wouldn't y equal -1, right? So when x is -2, y is -1. Now, when go forward, I need to find when x is -1, what's y? When I plug in y equals 1/2 of -1 plus 2 minus 1, I get y equals 1/2 of square root of 1 minus 1. There's that easy 1 that I wanted to square root. Well, the square root of 1 is 1, so 1/2 times 1, and minus 1 would be 1/2 minus 1, so -1/2. So -1/2. And then lastly, plugging in a 2, well, y equals 1/2 times the square root of 2 plus 2 minus 1. So y equals 1/2 of the square root of 4 minus 1. So y equals 1/2 of 2 minus 1. So y equals 1 minus 1. So 0. So when I graph this guy out, my points will be -2, comma, -1 is my first point. -1, comma, -1/2 would be my second point. And 2, 0 will be my third point. And so I get a graph that looks like this. Okay? Now, how do I find my intercepts? Well, again, to find a y-intercept, don't you just plug 0 in for x? So if I plug 0 in for x, my y-intercept would be, well, let's see, y equals 1/2 of 0 plus 2 minus 1. So y equals 1/2 of the square root of 2 minus 1. Now, do you know what the square root of 2 is? No, you don't know what that is. So we just leave it as the square root of 2. It's 1/2 times the square root of 2 minus 1. That's all I can do to simplify that. So my y-intercept is 0, 1/2 times the square root of 2 minus 1. And that's my y-intercept. Okay? Now, to find my x-intercept, don't I plug 0 in for y and solve for x? I get 0 equals 1/2 square root of x plus 2 minus 1. Well, golly, these are the problems that we were doing yesterday in your homework. So don't you just first isolate this radical by adding the 1 across. I get 1 equals 1/2 square root of x plus 2. Multiply the 2 across, so I get 2 equals square root of x plus 2. Square both sides to get rid of the radical. I get 4 equals x plus 2. And then subtracting 2, I get x equals 2. So my x-intercept was 2, 0. And in fact, hey, you know what? I'm a bad boy. We already found that out in our xy table, didn't we? I didn't have to do all that rigmarole, right? Okay. So that's the intercepts in the graph of the square root function, y equals 1/2 x plus 2, square root of x plus 2, and then minus 1. The domain of this guy. Well, the domain, doesn't this graph go to the left? You look to the left. Doesn't he start at -2? And to the right, he goes for infinity. The range, the lowest that he goes down to on the y is -1, and he goes up forever to infinity, correct? So that's your domain and your range. Okay? And that's how you graph that square root function. Now for cube roots, let's take a look. For this function, I have y equals -2 cube root of x minus 1 plus 3. Again, I need to make an xy table, but again, for this guy, I need 5 points, right? Now, I know I want, what are our favorite numbers to cube root? -8, -1, 0, 1, and 8. These are the numbers I want. What's my transformation to the x, though? It's -1, so it's actually an add 1. So if I take what I want and apply what I have, I'll get what I need. So if I add 1 to what I want, I need a -7. If I add 1, I get 0. If I add 1, I get 1. If I add 1, I get 2. And if I add 1, I get 9. If I plug these numbers in to this x, you're going to get nice, easy numbers to cube root. Okay? So let's do that. If I plug in -7, I get y equals -2 times the cube root of -7 minus 1 plus 3. I get y equals -2 times the cube root of -8 plus 3. So I get y equals -2 times, well, the cube root of -8 is -2 plus 3. So when you do that math, don't you get 7? So -7 comma 7 is my first value. Now when I plug in 0, when I plug in 0, I get y equals -2 cube root of 0 minus 1 plus 3. So y equals -2 times the cube root of -1 plus 3. And again, folks, there's that -1 I like to cube root. The cube root of -1 is just -1. And when you do the math, would you get 5? So when x is 0, y is 5. Okay? Now, I'm going to go ahead and do these last three as fast as I can at superhuman speed so that you guys don't have to watch the screencast too much, all right? Okay, so these are my y values when I plugged in 1, 2, and 9. You can check those out on your own if you want. Let's graph this bad boy out. So -7 will be over here, up left 7 and up 7, so like right there. Left 7 and up 1, 2, 3, 4, 5, 6, 7. So like right here. 0, 5 is over 0 and up 1, 2, 3, 4, 5. 1, 3 is over 1 and up 3. 2, 1 is over here. All right. Right here. My bad. Erase that. Okay. And then 9, -1 will be like right here. So now when I graph this guy, it comes in, slopes down, and goes that way. And if you look, it kind of looks upside down from the parent function. And it should, because don't you have a negative number there? That means a reflection across the x-axis. All right, so, by the way, I'm not going to do some of this math. I'm going to show you. Folks, isn't 0, 5 the y-intercept? So I don't have to do that math. Now, to find an x-intercept, what do I do to find an x-intercept? Don't you plug 0 in for y and solve for x? So let's do that math. Okay? So to find the x-intercept, I get 0 equals -2 times the cube root of x minus 1 plus 3. Well, again, now I'm just using my equation solving skills. I have to isolate the radical, so I subtract 3. I divide by -2. I get 3 over 2 equals the cube root of x minus 1. Now, don't I cube both sides to get rid of this radical? When you do, you get 27/8 equals x minus 1. Adding 1 across, 27/8 plus 1 is 35/8. So my x-intercept is 35/8, comma, 0. Now, if you think about that, wouldn't that be like 4 3/8? So let's take a look at this. See how accurate I am. 1, 2, 3, 4 3/8. That looks exactly like 4 3/8. Bam! All right. So those are your intercepts. And then the last thing before I leave you for the evening is your domain. Hey guys, for cube root functions, it goes left and right forever. Your domain is always going to be negative infinity, positive infinity for cube root functions, and your range is also always going to be negative infinity, positive infinity, because it always goes up forever. Well, other than me saying, that my favorite student is Kendall, I think I'm done for the night. Have a good evening.